Hello everyone, our project topic is Parallel and Distributed Mining of Association Rules in Big Data. This project is designed and developed under the guidance of our mentor, Mr. Anil Vasoya. Firstly, the need of this project. Nowadays, there is a rapid growth of data in organizations. Data is generated in hundreds of gigabytes or even terabytes. Every organization stores some transactional data. The data produced in such quantity must have some insights and knowledge hidden in them. Extensive data processing is a central point of information technology. In IT industry, we constantly work to process this data and find those insights. But mining of association rules in large database is a challenging task. They are tedious and time consuming tasks and humanly impossible. As we know by now that mining of these rules will produce insights that are hidden and produce potentially useful patterns that are beneficial for business decision. Next, the core objectives to be attained in our project are the two important aspects here in consideration are time and large datasets. Thus, we have to develop a system that can mine association rules quickly from larger databases. The main idea is to develop an architecture that can combine distributed as well as parallel computing in such a way that it will be efficient to find out frequent item sets from large database in less time. Most of the existing algorithms suffer from memory errors for large dataset. As data itself is in hundreds of GBs and our RAMs are merely of 4 to 8 GBs, thus our system should also be able to handle large databases efficiently than existing algorithm. Firstly, association rule mining. It is a procedure which aims to discover frequently occurring patterns, correlations, or association from dataset found in our retail databases. Here we are trying to find out how items are correlated or associated with each other. Next, parallel computing. Parallel computing is a type of computation in which many calculation or execution of processes are carried out simultaneously. In same PC, a large task is divided into smaller tasks and each of them are executed simultaneously. Distributed computing. Distributed computing is a computing concept that in most general sense refers to multiple computer systems working on a single problem. Here again, a large task is divided into smaller tasks, but instead of one computer, multiple computers are used to process this task. As we discussed the parallel and distributed computing, our system uses this concept to design our architecture, where our architecture's major task is to divide the whole chunk of large data set into smaller chunks, that is into n clusters. This part is done by the master node. Then each cluster data is provided to slave nodes and they start processing this data by applying ARM algorithms and produce frequent item sets. When all these clusters are processed, then the master node consolidates the results of all these slave nodes and produce the final results as global frequent item set. Next, the different implementation of previously defined architecture. Based on the partitioning and the multidimensional view of the datasets, there are two different architectures implemented in our project. First, the horizontal architecture, where the dataset is divided using the range partitioning method. Next, the vertical architecture, where dataset is divided based on category of items. Let's move on to a quick demo of our working system. Technologies and programming language used in our project are HTML, CSS, JavaScript, Ajax, PHP, and in backend, Python, MySQL, and Flask frameworks are used. Let's get an overview of our system. This is the landing page of our system. We have here different services like upload, the parameters page, knowing about the slave information, and going through our final results. After filling up this form, we can submit this form so that our task begins. Here, the master node is hosted on 5000 port number and two different slaves on 5001 and 5002 port numbers. Next, as soon as we have submitted the request, it starts processing. The master node divides the data into the specified number of clusters and start giving it to the slave processors so that they can process. Here slave 1 received cluster 1 and slave 2 received 3 clusters. After processing of each cluster, the data is returned back to the master where final execution rule generation part is done. After that, the final results are generated, which we can see on our website on the master page. After the completion of the task, the master dashboard will be updated and all the observations and patterns related to our task will be displayed. Following is the rule table, following is the pattern table. This was all about the working of our system.